Everyone. So that's what I get for muting everybody. I couldn't hear you all shouting. So anyway, oh, that's why that wasn't. Now I understand. Go back up here. So we just ran through these definitions. We'll have the presentation online, hopefully quicker than the last one. We had some technical difficulties figuring out how to get the recording that we made from the webinar, GoToWebinar, how to get that recording online. But I think we've got the kinks worked out now. So those should be appearing later this week. Anyway, a well is basically a facility that's intended to extract fluid. A borehole is a hole that's been bored into the earth with a smaller diameter relative to its length. And a well bore is an individual path. Individual wells might have multiple well bores. On the left is an example where it shows all the well bores sort of converging on what might be a single well at the surface, or might actually be some sort of drill floor like you see in offshore rigs that has a lot of well heads coming out on the drill floor. And the right is an example of one well that has multiple well bores branching at depth. So there are many well bores here and one well. But for most of the situations we're using simple wells, right? There's a single borehole, there's one well bore. The well, the borehole, and the well bore are all the same thing, and thus the general conflation of these terms in most of our conversations that can result in confusion if we're dealing with a complex borehole that has multiple well bores. The well origin and the borehole collar are identical, so that's where the well starts. If you have sidetracks and things coming off of a well, so that you have multiple well bores, then the collar for the sidetrack is somewhere in the subsurface. Most water wells we're dealing with, as a matter of fact, I think probably all water wells are just simple wells. We also generally assume that they're vertical, which, as we know in more complicated oil and gas type applications, is less and less commonly the case these days. For mineral exploration and engineering boreholes, these are boreholes that are drilled with no intention to inject or extract fluid, but they're designed to get information of various sorts. And particularly when you start getting into mineral exploration boreholes, it's very typical for them not to be drilled vertically. As a matter of fact, if you're down in a mine, you might have exploration boreholes that are collared in a mine shaft and then drilled upward. So there's a lot of those outside possibilities that you might have to deal with. But again, for our purposes in the geothermal data system, mostly we're dealing with simple wells, and so we aren't worrying too much about those wildly deviated holes that you might be doing in a mineral exploration situation. Although if somebody has a problem with those, we can talk about that because I think we can handle it. So what's the data associated with? One thing to remember is that in general, the data we're dealing with from wells is associated with a single wellbore segment. In the simple well, this doesn't matter, but if you're starting to deal with deviated hole or sidetracks and multiple wellbores in a single well, then you actually have to know which wellbore is this log associated with. Exactly where was the temperature measurement made. So the thing here is that the wellbore is what the data are generally associated with. And so we're dealing with logs, the standard E-logs that we think of various sorts, temperature measurements that may be made explicitly as a temperature measurement, but also more commonly what we have are the so-called bottom hole temperatures that are just the maximum temperature recorded on a logging tool during a log run, which is assumed to have been at the bottom of the hole, but I don't know how, if anyone's ever really tested that very thoroughly. We may be dealing with core cuttings, both rock and fluid samples that can come from various locations in the wellbore. And then also associated with any wellbore is a bunch of engineering information, which at this point we aren't dealing with very much, but that has to do with the casing and various kinds of completion type things, where the perforations are and what kind of treatment was given to the wall and things like that. The other kind of data that's generally associated with the well, not with the wellbore in particular, would be production data in general. Although you might have in the most complicated kind of wells, different production from different well bores in a given well. But again, for our purposes at this point, I don't think we need to worry about that. So as we dive into the data now from the real world into our world of computer information, we have one of the first things that I wanted to talk about was the question of identifiers. And so because we're dealing with a data system here, the linkages between various data items are important. So we have the well, and associated with that well there may be logs, cuttings, temperature measurements, fluid samples, geochemistry from the fluid samples, a lot of relationships between different data items. And the way we have to bind these together in our information system is to have a consistent system of identifiers and how we use those identifiers. So linked data, that's what this is all about. And the how is the tricky business in this. For most of the oil and gas wells and a lot of geothermal wells, depending on what states you're in, wells will have API numbers, which started out meaning, what is it, American Petroleum Information, but now it's run by IHS, is supposedly the steward of the API system. But each state, as I understand it, at least in Arizona and the places that I've been able to figure out, the states issue API numbers for wells in that state based on the regulations in that state. The other identifier that's important to think about are what I'll refer to as URI. URI means a Uniform Resource Identifier, and the Uniform Resource part is of debatable interest. But anyway, this means, think of it as a string that identifies something, a resource. And again, in this, I'll be using resource in a very general way to mean something that we can identify that we're interested in. So it might be an individual well log, it might be a well, it might be an individual well bore, it might be a particular sample. It's anything we might be interested in that we want to identify and link with other kinds of information. So what we are moving towards using, for reasons that should become apparent hopefully as we talk about this, is using HTTP URIs. So HTTP, as you're probably all familiar, is the identifier scheme that's used on the web to identify web pages. And in the standard convention that we're most used to seeing in our web browsers, the URLs that we see in the top of the web browser screen are identifiers for particular web locations. And when you dereference that identifier, that is, you say, what does this identifier identify? What you get back is a web page. In the information system that we're working on here, that gets generalized into this URI concept, the Uniform Resource Identifier concept, where the identifier might identify something that's in the world, a person, a well, a rock, that you can't send over a wire. So what dereferencing identifiers in a linked data network on the internet means is to get some kind of representation for the thing that identifier identifies. Hopefully that sounds kind of convoluted, but again, we'll talk about this as we go along. But in terms of how do we get these URIs? So in a lot of cases, we have to make them up. For the most part, if there's some kind of existing identifier scheme, we want to use that. So where there are API numbers for the wells or for individual well bores, because the API system is set up to identify down to individual well bores in quite a bit of detail, if you want to, we use those because they're there, they're understood, they're widely used, and people have some idea what they mean. One of the conventions, though, that we're promoting in the information system here is to add prefixes on identifiers that will identify the, quote, authority, that tell people something about, okay, what kind of identifier might this be, or who assigned it. So in the case of using API numbers, our convention would be to put API : in front of that. We have, for the wells in Arizona, we have permit files that are the most commonly used identifier associated with individual wells. So we use those, on those permit numbers, we give them a prefix for the Arizona Oil and Gas Conservation Commission, AZOGCC. We have other ones that we just assign from AZGS for samples that we have, or cuttings that don't have any other likely identifier. We can give them AZGS : and then have some string after that. And the reason for doing this is, one, to give people a clue about where this identifier might have come from, and secondly, to help enforce some kind of global uniqueness, because one of the important things about using these identifiers is that they are unique across the entire information system. So that by choosing these prefix strings that are unique to our organizations, we can maintain uniqueness, using that together with some string afterward. We don't have to worry about whether the following number or whatever we have there is going to be globally unique. So in order for these identifiers to be useful, there has to be some way to dereference them. And that means to get something over the web, something on the internet that tells you what that identifier is supposed to represent. And we've set up a dereferencing service through the USGIN with the idea of being able to dereference identifiers within the system. And it's a rule-based redirection. And I will, again, talk about that in a little bit more detail with an example. We switch over the browser here. This is something that Ryan Clark put together. But what we have set up is a server that allows you to define different kinds of resources. And the base URL is resources usgin.org URI-gin. And then the following part here is the authority. So we have AZGS defined in here. We have USGIN, and we can add other prefixes or other path segments here for other states if they want to use this. But what happens here is we define, using regular expressions, we can, this dereferencing service will parse the URLs that are coming in, and then using some regular expression patterns, figure out how to rewrite those and redirect the requests to some useful place where you can actually get something back. And I'll show this in action in a minute or two here. So this is how we make these HTTP URIs do something useful, is by having the beauty of HTTP, the hypertext protocol, is that we have this existing very durable and well-tested and widely used infrastructure for dereferencing identifiers. It's called the web. And we have the domain name registers and domain name servers all over the place, so that in general, if you have an HTTP URI that uses a known host, at least there's an existing infrastructure that can dereference that to some web location that hopefully will return you something useful. One other thing we have to deal with in thinking about the borehole data is where's the boundary between data and metadata? And this is a perennial problem. But the basic rule of thumb that I'd recommend at this point is the idea that if there's a file that can be retrieved on the web, then it should have a metadata record. So if you have scanned well logs, then the idea would be that there's a metadata record for each of those files that contain the scans. We have scans of all our permit documents. I think a lot of other states do as well, so that you would have a metadata record for the permit files. If you have a well log that's been digitized and it's in a spreadsheet, the easiest way to get that online would be to just treat the spreadsheet as a document, get it in a repository, and create a metadata record for it. Likewise with any kind of report. So any sort of information resource that's in a file, we can create a metadata record for and get it online and accessible, and that's the most streamlined path. But the more interesting case is if there's individual records that we can retrieve or deliver, then the idea would be to set these up as services. So for instance, with the wells themselves, if what we're doing is thinking of a well header as representing each well. And so you can't send the well over the wire. So what we have is a feature service, a web feature service that has a feature or a database record, if you want to think of it that way, for each well. And when you retrieve that record, you also get links to the data that are related to that well that might have their own metadata records. So the well feature, the well header record, might have the URLs that will get you all the logs, but each of those logs also has a metadata record that allows you to find the log directly. And we'll, again, look at this a little bit more. So the next thing I wanted to talk about here was we were just going to look at the templates. And the templates that we're working with at this point are for the well headers, well logs, and the temperature observations. So the well headers are going into a feature service where there's one record for each well. And if you have a situation where you have multiple well bores in a well, it's set up so that you can account for that. But again, you don't need to. And it's easy, in general, we don't need to. There's a location, so each well is represented by the point at which the well comes out at the Earth's surface, which we could call the borehole collar or the well origin or whatever. And then we have a related data field in there that has a link from that well, ideally to the other resources that are associated with the well. For the well logs, there's a well log template on the stategeothermaldata.org, but that's basically a metadata template. But it does have some other stuff in there, because what we found when we started going through this here at the Arizona survey was that when we were going through and cataloging our individual logs, which meant looking at the headers, it was useful to be able to write down, actually collect some of the other information on the header, which we didn't have yet, things like the maximum temperature recorded and if there was some casing information and diameter information. So that well log template that we have on State Geothermal Data has the standard metadata columns and the well header columns, as well as some of the other information that can be used to collect the temperature data. And what that means is if you use that template, so if you use, oh, that's not the template, sorry. Okay, so this is called well log data template. And I'm going to look at this view here that has all the fields in a column instead of, in each one in a row. If you collect all the information in here, it allows you to collect information about the log, temperatures recorded in the log, and the basic well header information. So that if this template is completely populated, it actually then could be used to set up a variety of different services, including the header service, a borehole temperature service, and the well log metadata. So it's sort of a multi-purpose template that actually feeds into three different services if it's fully populated. It doesn't have to be. And the reason it's done that way is just because of the standard workflow for collecting the information, at least the way we were doing it here, and that proved to be convenient. Oops. There we go. Okay, let's see, the other one is temperature observation, and subsurface temperature observation. I think it's called borehole temperatures. It's the other template that's out there. And that's set up, again, for collecting the basic well header information and then temperature measurement information. And that actually has some more flexibility in terms of what kind of temperature you might be recording. But the idea there is there's one row in that template for each temperature observation, and that gets implemented then as a temperature observation service. And those will be features where there's a point, a latitude and longitude, where that will correspond with a borehole collar, and then a temperature and ideally a depth at which the temperature was measured. So let's have a look at some of the actual data now. first I want to take a look and see. Okay, share, like we're good. Any hands raised? Oh, that's the audience view. Any questions? Let's see. I see a hand from Melanie. Are you there?
Actually, that was an accident from earlier. I accidentally raised my hand.
Okay.
Sorry.
Well, that's great. It actually works, though, so that's good. Okay, so there. Any other questions? Okay, Vikram. Is Vikram there? Maybe that's an accident, too. All right. Well, if you have any questions, shoot them off to Ryan. Or you can raise your hand, and I'll periodically have a look there. But what we're going to do now is flip over, and we want to look at, we looked at the header template. We'll look at the header template again. I don't want to belabor this a lot, but these are the header basic. This is the template here, and this is set up so there's one row in this spreadsheet for each well. It comes with some example data put in. Oh yeah, there's comments. If you mouse over the headers, there's some description of what's supposed to be in that column, which attempts to be fairly useful in explaining what's there. The other thing is, you notice, I don't know if you use Microsoft Excel outlining, but this stuff up here at the top, if there's groups of columns that you're not using, it's possible to just contract them. So you just hit minus, or you can just say, I only want to see the top level stuff. See this 1, 2, 3 over here on the left. So now we've greatly reduced the number of columns that we're seeing here. I mean, there's a lot of columns in this spreadsheet, and probably only a small percentage of them would be used in any given situation. The ones that are highlighted in pink here are the required content. So the well name, an API number, or other identifier, and because it was hard to do that kind of conditional. You either need an API or some other kind of identifier. Notice that in here, well, in this is example data, but there's an API number, but then this is an early version that says AZGS permit. That should be AZOGCC, but that's our permit number. There's also a USGS number here from wells, but I think I made that up, so that's just example data. Production, so what's required is county and state. Should be very easy, pretty much probably the same. A well name. The convention that we're suggesting follows what seems to be the general pattern as far as I could tell for oil and gas wells, which is there's an operator, a well number, and then a lease name, if all those things are available, or whatever is your local convention. There's a latitude and longitude. Latitude, longitude, the spatial reference system, which in general we in the services we'll use WGS84. It's a decimal degrees scheme. For North America, it's pretty much the same as NAT83. And then a location uncertainty statement, which is a free text statement, and that might say, in general, what we've been doing is putting in things like this. The location is from a protraction grid from a land survey system location, a township and range location, or if you actually have some kind of quantitative estimate on how good the location is, you can put it in there. There's a total depth, the reference point, which is the standard Kelly bushing ground level drill floor. If you have, there might be other conventions. The length units, which defaults to feet. And the other one that should be pink here is the information source, which is where it came from. But as you can see, if you open these things up, there's also places in here to include a lot of other details. And these were collected from a variety of different data sets with borehole data in them to populate this. This example doesn't actually have URLs for the related resources in here, but ideally it would. If we go, we'll show that in a minute, how that works. So that's the well header template. In this spreadsheet, that's also laid out other view, it's basically pivoted. And one of the reason that I thought this might be useful would be if you're actually doing the data mapping from a source field and data that you have in your own location. You can set up the mapping between your data table and the fields in this table as a preliminary to figuring out how you're actually going to get the data over into the template format. The other thing is it doesn't have to come in a spreadsheet. All we really need in the end is a table that has these column headings in it and the data in the correct format. Okay, I thought there was a question here, but I don't think there is. So anyway, that's the well header template. This is the one for the well logs, which has some additional information about the logs. In particular, the important things, there's an identifier for the log. Sometimes there's multiple logs from a hole, so there's different run numbers sometimes. If you're looking at the actual headers, a lot of time there'll be a recorded temperature, but then you want temperature units. The time spent circulation is important for trying to correct the temperatures. Also knowing the drilling fluid is a useful thing. And these salinity, mud resistivity, these other parameters here seem to be, again, from what we could tell, look like they're pretty common on log headers, so we were recording those guys. Where there's a paper copy, if you have one, and the important one is what's the URL for getting the file, if you have it. And if there's you might have a LAS file if it's actually been digitized and that's online, where's that? So those would be different representations of that log. Most of the stuff up at the top of this is exactly the same as the stuff in the well header template. So this is a sort of multi-purpose template for collecting the bottom hole temperature data, information about the log, and information about the well header. And this is just an example of a well log metadata. This is our populated table. So the titles that we put in for the logs, basically the kind of log and then the name of the well. Description has some basic image information about the log, which was largely cobbled together using a formula and concatenating values from other fields in our database. The publication date for the log we're considering to be the date when the log was run. Then there's this originator name and originator contact. The originator name we put in as the operator. And then there's our information about, because we actually currently have the log. Keywords, the convention we mentioned before, this is a metadata record essentially. So we have different keywords and they're separated by these pipe characters. So that's how we deal with a one-to-many relationship in a flat file. When this gets parsed and converted into a metadata record, those get mapped into multiple keywords in the metadata. The contact information, here's the latitude and longitude, the datum. So the extent maximum and minimum would be the interval that was actually logged. And in order to deal with one of the big problems with the vertical extent of the log is that conventionally we're thinking in terms of the log being from some top to some bottom interval measured from the surface downward. But in the metadata standards, the vertical extent maximum is the top and the minimum is the bottom. So that we follow that convention in the way we're populating this, that the maximum means the highest elevation, even though the number we're reporting is a depth below the datum elevation. So this would be this ground surface elevation would be the datum elevation. What we're actually reporting here is depth. And the way that's flagged is because the datum elevation is in sea level. The other way this could be done is to put the datum elevation at sea level and then report the height above sea level is the maximum. That would be the top of the logged interval, and then the bottom of the logged interval would be some smaller number that was actually closer to sea level. So that's a tricky bit. there. And it's, again, these are just conventions to try for consistency so that it's possible to search for logs that are between some different depth interval, as opposed to having to know the absolute elevation of what was logged. URLs for the logs, everybody has different ways of doing that, but in general, probably most people are following a similar pattern where there's a way to calculate this URL using in this case it's the permit number and the log type, and then all those are in some kind of file system, web accessible file directory, so that it's possible to concatenate these strings together and generate the URLs. I think that's probably fairly standard. And then finally, the related resource. In this case, the related resource we have for the well logs is the URI, an identifier for the well in which the log was obtained. And this is an example of a URI that we've got set up using our dereferencing service, so that I can copy that HTTP URI, plug it into a browser, and if things, oh, wow, that actually worked. So what we get back here is actually, this is from the web feature service. This is the feature for the well header where that log was obtained from. And you can see here's the API number. There's our AZ Oil and Gas Commission permit number, operator, mineral oil, all the other fields that are in. This is a well header record. So the fields here in this XML document, these names you see here, you would recognize as being the column headings in the well header template. So those template files get mapped into these XML schema in a very, very simple way. It's just the column headings that you see in Excel are the XML elements in the XML element names in the documents. Now, of course, there's a name. We've generated a namespace here for the elements just so that this will work, and it's just AASG namespace for now. That's not super critical, but it does give us a way that as the system evolves, we can have different versions of these schema that will be in versioned namespaces, so that it's possible to evolve the system while maintaining backward compatibility with working services and XML schema. The other thing to look at here is, you notice what I pasted in here says resources USGIN org URI AZGS well, and then here's the actual resource-specific identifier. When I dereference that, I hit enter, you see the document that I actually got was returned from a pretty different address here. And this is actually what's in here. If you know, there's a bunch of stuff here. This is a WFS request. So what's happened is that this, the resource identifier got fed into this resources.usgin.org website, which has the dereferencing service. It saw that it was a URI GIN AZGS well, and it knows that given that it's a well, it takes the end of that and knows how to rewrite the URL to set up the WFS request, send it to the feature service, and so it gets redirected, and what the user gets back is this XML. So this is the reason for trying to use these HTTP URIs. And for those that are interested in, we can go ahead and set up rules in our dereferencing service here. We can create namespaces for each state survey, and they can decide how they want to rewrite the URIs to have them point at the documents on their server. If that turns out if that's a useful thing, which I think it should be, but hopefully we can make that work. All right, so that was the well log metadata example there. Stuff. Let's see. Let's go back over here. I've got a shape file and the service. So now we're going to switch over to looking at stuff in ArcMap. All right, so what we've got here in ArcMap is just an ArcMap project. See all the little red dots there? Those are temperature observations. We haven't actually rolled this out into the observation service yet. This is actually, this layer in my ArcMap project is connected to a shape file but this shapefile will be exposed as the observation service. There's still some cleanup work we're doing in here. One in particular, there's some issues we've got. We've got temperature observations that we don't already have well header records for. So you see there's well headers in here that have ADWR identifiers. So those are water wells from the Arizona Department of Water Resources. And this number here, 617-807, is a Department of Water Resources well registry ID. So in this case, we generated a URI for that well using the Department of Water Resources identifier number. In other cases where there's no authority that we know of that has an identifier set up for a well, we've adopted a convention of using a prefix, a system like this, where the prefix is AZ for the state, and then we have a county abbreviation. So there's AP for Apache, here's NA for Navajo, and then the rest of the identifier works like the GWSI, the USGS groundwater site inventory identifiers, which is, if you look at this, it's basically a latitude to 4 decimal places and a longitude to 4 decimal places. So that this gives us a way for arbitrary wells that we don't have any other kind of identifier for. We're using this convention, county, latitude, and longitude. So by having the state and county abbreviations in there, it gives you a way that you can parse these pretty quickly and do text-based searches for wells in a particular county if that's useful. And by using the latitude and longitude, hopefully at least wells that are close together will end up with identifiers that are similar and might help to try to deduplicate some of these wells. We've spent a considerable amount of effort inspecting these. Esti's been doing a lot of this stuff. Running through in ArcMap and where we have multiple databases with water wells and temperature data from wells from another source and USGS data, trying to figure out when we've got the same well and when they're actually different wells with different measurements. So this is the temperature observation table, largely populated, that we'll be rolling out as a service here soon. Right now it's a shapefile. And this one here is actually the well header feature service. And the nice thing is this is coming in as a feature service into ArcMap. We've connected to it. And you see when you look at it in ArcMap, it ends up looking pretty much exactly like the shapefile does. It's got all this, it looks like a table. You can do the same kinds of searches. If we wanted to, I'm going to turn this one off. I'm going to turn the well headers on. See, not surprisingly, there's a fair amount of overlap there. If I decided I wanted to symbolize on unique values, I could pick something like, how about well type? And, outlines. Pick some crazy colors. Say OK. So there's the wells symbolized by well type, and you see most of these are the same. They're probably oil exploration wells. Not sure. I'm not going to spend a lot of time looking at that. So this is the well header feature service. I didn't pick a very good field. Most of them are the same. There's different ones. Anyway, so that's the beauty of setting these services up as web feature services is that you can use them with ArcMap out of the box. In order to get this to work in ArcMap, I should mention though, you have to actually, when you install do your ArcGIS installation, you have to do you have to go to custom on the installation phase and tell it you want the interoperability extensions. They won't get, if you just do the typical install, you don't get the interoperability extension. But in order to connect to the feature services from ArcGIS, you need to have that installed. So it's pretty easy to go back, and as long as you have access to the installer, and update your installation with that. And then you can connect to the feature services. So that's what the borehole data will look like coming in here. Okay, actually there was something else I wanted to point out with these guys. Let's pick a well here. We have the related resources populated. Now unfortunately ArcGIS doesn't do a very good job of displaying. There's a long field here, but you can see there's a bunch of associated resources. And what I'm going to do here is mine that out of there. And let's have a look at the temperature log. So that's all the stuff associated with that well. And we can cut that out. And if we had a fancy client, you could parse that field and display it to the user in a more useful kind of way. But it makes it pretty easy to, from a given well, hopefully it'll be, with a good client it'd be easier, but that's a big file, 17 megs. That's so big. All right, there's the temperature log. Must be a deep hole. All right, well, we're not going to fool around with that too much. So that was the other thing. So that's the advantage of populating that related resource in there, is it basically gives a quick and easy way to get from looking at something on the map to at least access the other stuff that you've got available for it. Back to you. Oh yes, one other view, the metadata view. So and this is just coming in, if you're coming into the catalog. So now for the well logs and the other things for which there are files accessible online that have metadata records, then you can search for the actual logs. And in this case, we have some Kentucky data. What's going on here? Let's see. KGS, yeah, okay. So again, you can look at the metadata details. And where's details? In this case, let's see. There's an online access. So there's URL. We can access the log directly. There's the log. So in this case, so what we did here is we did a metadata search in the catalog. We searched for, well, any well log from Kentucky, but the metadata has the linkage that points you at the actual resource, in this case a scanned log, so you can get it. If you come in through, this is the GeoPortal, any CSW, Catalog Service Client, can search this catalog because it's implementing the standard catalog service. Now, this guy lets you go directly. If you do this, it recognizes that it has an online resource, so it gives you this open, you can open it directly if it knows where it is. So this one, that one works. So that's the catalog access. So when you create the metadata records and they end up in the catalog, then they're accessible by this means. And we did that, and so that was the end of the formal presentation. If there's any questions, let's open it up. You can see how to raise your hand there. We can do that, or I don't know, Ryan, have you been, let's see what's in the questions. I can't read that. Oh yeah, let's try, I'm going to try unmuting the attendees. Let's do that. I guess I have to go through, do I have to go through each one? All right, so I'm unmuting everybody. Let's see if you're not using your microphone and to speak, try to mute it so we don't get any kind of weird feedback going on.
Steve, this is Jordan.
Yeah, Jordan, hi.
Hi there. Do you have a list of log types worked out?
In the, sorry, hold it, yes. In the template here, there's a collection of log type codes here on one of the tabs. Can you see that?
Yes, I can.
So it's in the back of the template, and this was basically, well, you see I've got the references for the sources here. So I just sort of ferreted out. I think I found 3 or 4 different collections of one from Ontario, one Bill Harrison stuff from Michigan, and then the log types that we use here for our logs, and assembled them all together and then tried to conflate them. So there's one list here which is just everything that I got. And then what I did is I tried to go through and identify things that were actually the same kind of log and reduced it to one set of codes here. So if, what I'd say is first check that list if you're trying to figure out how to classify the log. And if that doesn't work, then we'll need to add stuff. So if I get data coming in, if we identify, and I'm sure there's lots of other kind of logs out there. There's a fairly long list. There's a lot of weird stuff on here that I have no idea what it means. We got almost 500 things here. But there's other ones out there, and I'm sure they're inventing new ones every day. So.
Yes, they are. Sometimes a different question. Sometimes logs are run over midnight.
Over midnight?
Yes. So
a question we've run into is whether to date a log by the first hour and minute or the last hour and minute.
I guess my immediate question to that, and maybe there's other people out there that have can provide some useful input on this, is does it make any difference? What would be the use case where it would be important to know when they started logging versus when they finished logging? If
probably,
it doesn't make any, sorry,
probably that doesn't make any difference by itself, but when the log header carries 2 dates and times and the record doesn't agree with the date and time that the user first sees when they open the log, it's discouraging.
Right. No, that would. Diane was asking if you could put two times in the date and time field here, and that won't. That would not work because.
Well, that wouldn't really help the situation anyway, because sometimes they do reruns on the same logger will, as you said, run multiple times, and those runs have different times, and sometimes that's of importance. So there really isn't any bound on the number of times and dates that are interesting once you start exploring the data.
Right.
I think we just need to take a position with regard to whether it is the first possible date, the last possible date and time, or indeed whether we're going to include a bounding range of dates and times for a log set in the same way we talk about an interval for geothermal logging in depth.
I guess my first, gut reaction to that would be to just use like the last time, so when they finished logging, because I don't right offhand see any use case for knowing having the interval recorded in structured data fields. What I would say though is that we in situations like that, that's what I would say this notes column would be handy there, and it would be useful to say, that this log was run, over midnight or something, started on this date, finished on that date. And if you can construct something like that in the notes, I know if you have thousands of wells, you can't go in and be typing notes for each one, but we've found in a lot of cases, if we have that sort of information, we just have been able to construct strings using concatenation in the queries.
Sure. I guess the issue is, once again, just sanity. When the log comes up with a different date than the catalog shows for it, it puts people off.
Right.
And sometimes, indeed, often the same well will be logged repeatedly in a short period of time, checking for flow conditions, for example.
Right. So,
Okay.
so in our case, we had situations where we had four logs that were run, in a series over the course of a day or two. Sometimes there were different runs, but they were a week apart or something like that. But those show up as those have separate metadata records.
Right.
So for some of the wells, you'll see, there'll be multiple metadata records that look like it's the same kind of log from the same well, and then you start, when you look into it, it says, run 1, run 2, run 3, like that. So,
a question with regard to temperatures. This is associated with well headers rather than logs.
yeah.
I wasn't clear whether you're suggesting that we simply keep track of the maximum temperature or the bottom hole temperature or both.
In the well header record, flip over to that template. And I'm actually, the reason I'm looking at this is my memory is fuzzy. I'm not sure that we actually have a temperature in the header record. No, the well header record doesn't actually have a temperature in it. So in the temperature observation, there is actually, I guess I should go ahead and open that. Let me open the temperature observation one.
Did we talk about that? I don't remember you talking about that.
I got lost in the haze.
Oh, okay. No, I thought maybe I'd gone to sleep. Sorry.
Inconceivable. All right, so this is the template. Let me get that out of the way. For the temperature observations, and here there's a bunch of stuff for recording the conditions in the hole, drilling fluid stuff. But in here, you'll notice there's a maximum recorded temperature and a measured temperature. So the idea is that the maximum recorded temperature here is the kind of maximum temperature you find on a log, where you don't actually know for sure where that was measured, but you assume it was at the bottom of the hole. The measured temperature, the idea of this is where you actually were explicitly measuring temperatures and recording the depth that you were measuring it at. There's a place for both of those. And then you see there's a place to put corrected temperatures if you've done corrections. Temperature units, which in general should be consistent throughout at least. Time-sense circuit. And the important one here is the measurement procedure. So the idea here is that if it is a measured temperature, there's some description here of what kind of instrument you were using or something to indicate how that measurement was done. If it's just a regular bottom hole temperature, the measurement procedure would say bottom hole temperature. If there's a correction, you can say what kind of correction was done. If it is an actual measured temperature, there's the depth at which it was measured. So for instance, there might be situations where you have a measured temperature that's the average of 8 or 10 measurements or something done at the bottom of the hole or something like that. I mean, that would be one kind of, there's all kinds of different approaches you might take to measuring a temperature. So it's important to record the procedure that was actually used to give that number.
Gotcha. Steve? Can you hear me?
Somebody else out there, who's that?
This is Mark. How are you? Great job. Martin K.
Oh, hi, Martin.
Just a couple things. So with regard to the temperature, we as a group at SMU, or the group is working on a temperature template. We're almost complete with that and wanted to share that. So I think that there are some things there. I'm not sure if it's going to be captured in 2 places, but I guess once we actually share it, we can work through that.
Yeah, so the sooner the better, because what I would like to do then is what we'll do is, basically all these templates are versioned, right? So
Right.
This is 1.0, and hopefully we can basically reconcile and harmonize, if you have whatever you come up with for a
Yeah,
template?
we do. We're waiting. We're working with USGS because they had some input as well. So I would say we're probably a week away, and we've kind of worked through as far as temperature. Just keep running it through all the temperature masters to get their feedback. So I would say within a week we should have, a pretty solid template specifically on temperature.
Great. And I guess I'm also counting on you guys for a heat flow template too.
Yeah, well, that's what it really is a heat flow template, but I'm just kind of mushing them together.
Okay.
So,
well, that'll be
they're in some ways one and the same, but you'll see it. So I'll probably get you an early version, and then we can have a more final version pretty soon here.
great.
The other thing is, just going backwards, with regard to time, it's important that we know circulation time just so we can make corrections. So, meaning that the time in which circulation, the period between the beginning and the end of circulation time is critical, and that oftentimes will go overnight. So if we know it's 6 hours or 8 hours or whatever it is, so when we actually make the corrections, that's certainly an important component of that correction.
So it's not just the time since circulation, but it's how long the well was flushed.
Exactly.
Yeah, okay.
So I think that it's important if you're going to, that data component needs to have not only, it needs to be a 24-hour clock, but it also needs a date so that we can, calculate that.
Right. So
I'm just throwing that out there as a consideration.
Right.
And then the third one is, I think that the only more important thing with time is just to identify dupes, because I think that it's certainly possible that multiple people could be submitting the same log, and I mean you can find the dupe based on depth and API. I mean, there's a lot of ways to identify dupes, but certainly if we had a uniform way of actually timing it, you know what I mean? Okay, we have 2 that are on January 14th at this time. Well, that's probably a dupe. So I think that I think that if we can come up with a uniform way, there is a use case for, choosing one or the other.
Yeah,
It's
okay.
certainly going to be a whole lot easier to do, to find the dupes.
Well, let's see. Which would make sense if we were going to choose either when they started?
I think your suggestion, which is the end time, makes more sense.
Okay.
Personally.
Yeah. All right. Well, I was just sort of throwing that out there for kind of in an arbitrary sort of way, but it makes sense.
Yeah,
so let's for
that's
now.
When it's over. I don't really care when it started. I only care when it's completed.
When they were done, yeah. Okay, so if there's some ambiguity there, use the time when the logging was completed.
Okay.
Thanks.
That's great. Thank you.
Hey, Steve. It's Steve Cortaviola.
Oh, hi, Steve.
Yeah. I was working on those log curves this morning, and we came across a site, www.spwla.org, which has all the mnemonics for, it's the Association of Petrophysicists and Well Log Analysts. And they have all the mnemonics.
What's that URL again?
It's www.spwla.org. That's the Society of Petrophysicists and Well Log Analysts. And then under their technical resources, they have mnemonic listings out the wazoo. I mean, you have enough. There's at least 1,000 of them. So
okay.
We're going to try to organize them and then submit them as maybe standardize a few thousand.
Great. Okay.
It's a great site for people working with the well logs. But
right. I never found that one. Thanks for the lead.
You won't thank me after looking at it.
I see Bill Harrison's online. I stole your list, Bill.
I don't.
All righty. Any other questions?
Yeah, Steve, the one I've been asking, it's Cortaviola again. What happens if we've submitted some metadata, and we already found a problem with mine because I reversed my depth. So you wanted the minimum and maximum reversed. How do I correct them? Do I correct them or just resubmit them?
Probably the easiest thing is going to be to just, because what we did is we put those in a web accessible directory directory and then harvest them into the catalog. So what we'll do is just rewrite, you know, if the files come in with the same name, right, they'll replace the pre-existing one in that web accessible directory. And what we'll do is just reharvest it. So let's try that approach.
Okay. Will do.
Great. All right. Well, thanks very much, and we'll be back again, hopefully in less than a month. And oh yeah, we have the new website should be rolling out any time here. Let's see if we can. What is it? Test.org. So it's still a site under maintenance. Oh, isn't she clever? Well, Pam isn't letting us in yet. Okay. Well, anyway, stay tuned, and we'll have a new and hopefully more easier to use and cleaner looking website before you can say Bob's your uncle about 10,000 times. All right. So that's all from here. And thanks a lot for tuning in. And let us know if you have any problems, and keep that sample data coming in. We've got a new hire here. Celia Coleman just joined us this week, and hopefully that'll help to start unjamming some of our data backlog, and we'll see more data start coming out, some of the test services and stuff. So good work, everyone, and off we go. Bye now.
Thanks, Dave.